Swayam Prabha. Digital India. Educated India.
Okay, welcome to this video lecture series on basic surveying, and today we are in module 11. It's a new module which we are starting today, and this is about project surveying. Today we will start with lecture number 1 in that. This is the overall program of our entire video series lectures. What we will cover in the project survey is written over here. This is in lecture number 1, lecture number 2 and lecture number 3. So first of all, we will be talking about the concept of setting out. Why we need to set out. We will see one example. Then we will see the use of control stations in setting out and what are the basic procedures for setting out. Later on, we will see the error sources and what precautions we need to take, and finally, what is the tolerance level, permissible error which is there, and how to take into account that thing. In addition to this, in our next 2 lectures, we will be talking about some particular projects. For example, in the second lecture, we will talk about the curve. If there is a curve and we want to set out the curve in the field, what is the procedure for that? Then later on we will be talking about the road and the building, how to set out those in the field. Well, to start with, why we need to set out? That's the basic question, why we need to set out. Before we get into that, what we'll try to do, we'll try to see a typical life cycle of a project at initial stages. When I say project, I mean any civil engineering project. Okay, it may be a bridge, it may be a building, it may be a road, it may be a dam, any civil engineering project. What is the life cycle in initial stages? So we will see that by one example. The example here is, we want to have a road and a bridge in the area. Well, over here in the screen, I am showing you the ground. This is ground. So right now we are seeing the ground, and the ground is very large here. For example, let's say this entire length is of order of 2 kilometers, and as well as the width is around 750 meters. So it's a huge area. What is desired here is, starting from a point A, we want to go to point B, while there are jungles in that area as well as some habitation. So this red is the symbol for habitation, and these are the symbols for jungles, and rest of the area is barren fields, while this particular feature here is a water body. Well, we want to have a road and a bridge which will join these 2 places. Or for example, even in road and bridge, we have some questions which we are going to raise now. So if this is the project, we want to join these 2 places A and B, what should we do? You just think yourself, you are standing on that ground. Right now I have brought that ground onto my video screen, on your television screen. But think that you are standing on that ground, and while you are standing, you want to have a road between 2 points A and B which are around 2.5 kilometers apart. Now how to do that? Should we start from one village and start going to the other? No, that's not the way. We have discussed the principle of surveying also, which is very important principle in anything. We say whole to part. First we should know about the whole thing. We should do the reconnaissance. We should come out with the best possible project. Well, how can we do that? In order to come out with the best possible route between these 2 points, what should we do? We should be able to do something so that we can see the area synoptically. The entire area in one go. We can see all the features which are there in the area, all the landforms, all the obstructions, all the habitations, all the forest types, all the quarry sites. we should be able to see them, assess them, and then accordingly we will decide about a route. Now how do we do that? Obviously we know that we would like to make a map. So we would like to map this area. That particular entire area, we would like to make a map of that. Okay, now we want to make a map of this area. Now in order to make a map of this area, as you can see, we will have to decide about one technique. What is the technique that we are going to use for making a map? We will have to decide about the instruments. Okay, less about the techniques. In techniques, if you observe this area, and we have decided that we are going for triangulation. So first of all, as you know, we would like to do the reconnaissance in order to locate those points which can serve as the triangulation stations. And there are some requirements. We know once we are talking about the triangulation, we discussed what are the points which we should keep in mind in order to locate the triangulation stations or the survey stations. Well, keeping those points in mind, let us say we decide that these are the locations. You can see these locations here now in blue. So these are the triangulation stations. Well, if these are the triangulation stations, what we will do, we know the procedure of triangulation. We'll measure the angles, all the angles which are possible there. We'll measure one length out of all these lengths which is possible to be measured easily. So over here, what we are doing right now, we are forming the triangulation. Right here, we are assuming that the intervisibility is possible. That is why we have taken the line of sight through jungle. Similarly, here also. So that's our triangulation network. One of the lines, for example, this line can be measured easily. So I'm drawing this line now, I'm rather highlighting this line. So that's our baseline, and then we measure rest of the angles. All the angles are measured, so we know now the triangulation can be done, and we can compute the coordinates of all the points which form our triangulation network. Well, having done the triangulation, what is the next step? Triangulation means we are collecting the skeleton of the area. So in our drawing sheet now, where we are going to make the map, our skeleton is plotted because we know the control points. Then rest we plot the details. We have seen the details can be plotted by plane tabling, or maybe in this case, let us say we are doing the plane tabling or intersection by the theodolite, or maybe by taking the offsets. So whatever the method, we are plotting the details. So by this method, we generate the map. So here it is, map of area, and the other details, the graphical scale, the scale written as RF, representative fraction, the details, who prepared it, and as well as the legend and other thing. This is plotted in the map. Well, we have the map. What next? The maps gives you a facility to look at your area in a synoptic way. The entire area, all the habitations, all the forests, everything is possible that you can see in one go. So maps, they make it possible to plan your project. Well, so after completing this step number 1 in the life cycle of a project, which was surveying, I'm saying here making the map, or we can say surveying in general. So we are doing the surveying as the first step. The second step is, on the surveyed thing, we are doing the project planning. So this is the second step. So what is the meaning of that? Well, project planning means, on this map, now it is map, and I can work on this map. I can come out with various routes. For example, I decide to choose a route like this in order to join to these 2 points. Well, someone else, he says, no, this route is not good. Rather, we should go for some other route, and he chooses a route like this, where there in between will be a bridge. And someone says, no, even he wants to take a different route because of some reason. The reasons may be different, and his route is maybe something like this, and the bridge is here. So while we are doing the planning using the map, it is possible that we can come out with various routes, and then we go for the optimum one, or the optimal or the best one, the best route which is possible under the circumstances. Okay, if that decision is taken and we say, well, this is the best possible route, so other routes are not taken into account, so this route along with the bridge is marked on our map. What is the next step? Now the route means the road and the bridge, they are on the map. What we should do next? The third step. The third step in life cycle of the project is transferring the project onto the ground. So the road and the bridge which are there on the map sheet, or because I am giving the map sheet as an example, it may be in our computer also, because we can do the planning on computer. Our map is staying in the computer. So from that planning stage, we want to take that project onto the ground. Now how to do that? That's the question. And this procedure of taking the project from map sheet or from our drawing board to the ground is called setting out. Well, how do we do setting out? Now in this case, if I go to the ground, let's say we visit the ground now. We have a map sheet with us, and on that map sheet we have the road and as well as the bridge location plotted. Now we are visiting the ground. If we visit the ground, still there on the ground there is nothing. The ground will look like as I am showing you here. The ground will have only our control stations which we had marked earlier, and these control stations, when we fix these, we fix them in such a way that they will stay there for longer periods. So after 2 months of surveying, when we visited this area, still the control stations are there. So we have the control stations, and as well as the other details, the rest of the ground. And what we have to do now, I have to see that how my road and my bridge will come, and where exactly will it come. We do not know right now whether it will be, whether it is here, whether it is here, whether it is here, and that is the question. There on my map, its location is only one location, as you can see in the map. So what we need to do now, this is important. The way the project has been planned on my drawing board, on my drawing sheet, on my map sheet, we need to transfer it in exact details onto the ground. So we need to transfer the project exactly onto the ground as it had been planned. Exactly means, it's the relationship of the project with the landscape. The geometric integrity of the project, that should be also transferred onto the ground. So the project, the way it has been designed, in a relative sense in itself, the project itself, as well as the project, the way it has been laid out on the map sheet in relation to the landscape, that has to be transferred onto the ground exactly. So this is the procedure of setting out. Now how to do that? So over here in the ground, as we discussed, we only have our control points. So what we would like to do, we would like to make use of these control points which are also there in the map. So what we will do here, they are on the map with respect to these control points. We will try to find where our project is. For example, if there are some points on my line, let us say the road which was planned is, that's the road which was planned finally along with the bridge, and we want to now locate some of the points of the roads there on the ground. So what can I do over here? Let's say in order to locate this particular point, I can measure its angle and as well as this angle. So two angles, alpha and beta, if they can be measured on the drawing sheet with respect to station A and B. So what I can do, I can go to the field, set up this line by having the ranging rods here and putting the theodolite over here. I can measure the angle as were there, alpha and beta angles, because we had alpha and beta angles. So same what we'll do, we'll set out alpha angle and beta angle there in the field, and wherever they intersect, that's the point which is located now. So what we ensured here, we ensured that the point has been located where it should be as it was there in the map. Similarly, any other point, a point for example here on the road, this point can be also located using some other control points. I'm just making use of two angles, alpha dash and beta dash. So a point here can be located by, if you go to the same set of stations, so from these two, alpha dash and beta dash. So this point is also located. Similarly, we can locate various points of a project along with the bridge, and the entire project will be located there on the ground. So what did we do? We made use of the control points. This is important. What we did, we went to the ground, we had the control points already there, we made use of the control points in order to find the coordinates of the project on the map sheet, as well as then transferring those with respect to the control points which are there on the ground. So by doing that, we are able to set out the project there on the field. So in this, what we observe, our observations are, well, we of course setting out is a very important activity, and for setting out we need a network of 3D control stations. This is required. Then how about the setting out method? I just discussed one case where we were measuring two angles alpha and beta to locate the point of intersection, and these two angles alpha and beta were same as these were in the map. Not always this is possible. So sometimes we have to go for some other method also. So the method which we will use in the field will depend upon the field conditions and the project requirement. Each project will have a different requirement. Whatever we are going to set out will have a different requirement. Our method will depend upon that only. Well, what we'll do now, we'll talk about the various things which come in this procedure of setting out. We'll start with control stations. What is the role of control stations? We know it. Control stations means they are established in the field as well as in the map. They help in making the map, as well as they help later on in finding the relative position of project on the map sheet, and then we take that relative position to the ground. So control points are very important. We know about that. Next, it is important, because from the duration, the duration between the very first survey in the field when we are making the map, from that point to the point when we are actually transferring the project onto the ground, could be a long duration many times. It might take 1 year when we did the survey, and later on when we actually transferred the project onto the ground. The planning stage, the design stage took around 8 or 9 months. It is possible, or sometimes it may be less also. But in any case, whether it is more or less, whatever, we need those control points there on the ground. Those control points which we used for surveying should stay there, because they help in the process of setting out. Now, in order to ensure that they are there, we need to protect them. How to protect them? There are various methods. For example, you can make very big concrete blocks and insert them into the ground. Like the stations we discussed when we were talking about the triangulation. We discussed what is the the standard method of making a station. Make proper stations which are embedded there on the ground, so they will stay there. In addition, sometimes it is possible, if you are working in a very busy construction site, it may be possible that one of the stations may get damaged. Some excavation is going on there, so that station may be damaged. So what we need to do, we need to protect our stations properly. There could be varieties of methods of protecting it. Just one example here. One example here is, this is a concrete block which is embedded there on the ground, and as well as what we have done, we have protected this station by these wooden planks, and as well as we have written over here about this station. Well, what is the RL of this, what is the chainage of this, and something like that. So the method may vary, but the important thing is we should protect this station. Not only protection, many times, even if we have protected the station, but it is possible that in that busy site, someone came with heavy digger and he dug that entire area. So that station has gone away. That was a very important station, but it has been dug out. Now it is no more there. So in this kind of situation, what we need to do, we need to go for referencing of station also. So not only we establish the control stations in the field, rather we also take their references. Now what is the meaning of references? Even if the station is not there, we should be able to locate the station. How can we do that? When we are establishing a station, for example here, over here a station is established. This is a concrete block, and this concrete block is embedded there on the ground, and when this concrete block was established, that's the point of the station. Along with this, we establish some more stations, or rather some more concrete blocks. What they serve, if I stretch some thread between these 2 points, it intersects exactly over the station. So even if this station is damaged, by using these A, B, C and D stations, it is possible that we can locate its location further. So over here, this is our survey peg. Survey peg means our survey station, while these are our referencing pegs. Referencing peg means which we are using for the referencing. Many times, if there is a survey station, we would like to reference it with respect to some permanent objects. Let us say there are one electric pole and 2 buildings, and I measure the distance of my station from these 3. So these distances are known. So by using these also, we have generated some references. And even if this station is damaged later on, it is possible that because we know the distance, we can further locate it after some time. So this is why we need to generate these references. Now we will go for the basic procedures which we need to follow in setting out. So basic setting out procedures. We'll talk about these one by one in detail, but overall what we can say, the plans or our maps are always on a plane coordinate system. If we have a map, our map has a coordinate system with it. Always we can assume x and y, that's the coordinate system along with the map. Now on that map, we have designed a particular building. For example, this is the building, let us say. So salient points of design are also in the same system. Well, salient points means those points which I can make use of in order to locate this building. So these are the salient points, for example. So these points, point number 1, 2, 3, I can find their coordinates x1, y1, x2, y2, x3, y3, also in the same system. Now, once we have this information, we use this information for setting out. Now, this setting out is done basically by 2 methods. One we say polar coordinate method and intersection method. And we are not limited always to these methods. This is important. What I am giving you here is only only just idea about some methods. But actually when you work in the project, actually when you are working in the field, you have to come out with a method which may have a bearing on these concepts. So these methods or these terms or these procedures which we are discussing here are only the conceptual things. There in the field, when we are working in the field, we have to base our final solution on these concepts, but our final solution may be entirely different. So what we'll do now, we'll talk about these methods one by one. Well, we'll start with this polar coordinate method. Now, what is the polar coordinate method? In polar coordinate method, if we have the controls A, B and C, and here we had the map. On that map, A, B and C are there. There on the map, there was a building corner. Let's say this is the building corner, D, and this building corner needs to be established there on the ground. So what we can do, I can have a reference line, and from this reference line I can observe the angle. I can measure this angle alpha, and also I can measure the distance L. So this is the polar coordinate system over here, and what I do now in the field, I go to that reference line BA, and from that reference line we'll set out angle equal to alpha, and then on that length alpha we will set out the distance L. Of course, this L will be multiplied by the scale because we are working in the field, scale of the map. So this is the point D, and this is the first corner of our building which has been set out now. So this is the method which we say polar coordinate method. What we observe here in this case, we had to set out angle and as well as length. So the question comes now, how to set out angle and how to set out the length? What should we do? What are the methods for this? Okay, we are going to now discuss about the setting out of angle. I give you one example. Let us say the angle to be set is 43 degrees, 26 minutes and 40 seconds. And we have a vernier theodolite which has a least count of 20 seconds. How to set out this angle? Well, if you remember, when we discussed the vernier theodolite, in case of the vernier theodolite, there were two scales, the main scale which was there in the bottom and the vernier scale. In vernier we had vernier A and vernier B, and that's the main scale which is graduated from 0 to 360. When we rotate this vernier, along with this vernier the telescope also rotates and the angle value changes. Now the vernier is used to read in fractions of, or rather with the least count of 20 seconds. Okay, in the main scale, if you remember, in the main scale we can read up to 20 minutes. The least count of the main scale is 20 minutes. So keep that in mind. The least count of main scale is 20 minutes. Least count of vernier scale is 20 seconds. And this is the angle which we need to set out. So the procedure for this is, first of all, in our vernier, we look through the eyepiece, and in our vernier, we will set out an angle of 6 minutes and 40 seconds. So this is the angle which is set out in the vernier. Initially, for example, in this problem itself, initially when we are looking in this direction, the reading is 0, 0, 0. That's the reading. And now we set out in our vernier 6 minutes and 40 seconds. Now what we do next, rest angle, that is 43 degrees and 20 minutes. This we change, or this we read, or rather we rotate now our telescope, because already the 6 minutes and 40 seconds angle is already rotated. So now we rotate our telescope so that the angle on the main scale is 43 and 20. So the total angle that will be set out is 43, 26 and 40 seconds. Now this is an not very difficult thing to do, but there may be a rather little difficult situation when the angle that we have to set out is not in multiples of least count. Over here the angle is 43 degree, 26 minutes and 43 seconds. When it was 40 seconds, it was fine because the least count of vernier is 20 seconds. But now it is 43. We cannot set out 3 seconds with this instrument because its least count is 20 seconds. So what we do? Well, that's our reference line. From this reference line, first we set out the angle as we just discussed, which is 43 degree, 26 minutes and 40 seconds. That's the angle which we set out, and it is possible to set out this angle. Next, what we do? We again observe this angle by repetition method. Though we have set it out, but naturally there will be some error. So what we do? We observe this angle again by repetition method, and let us say by repetition method this angle comes out to be 26 and 41 seconds. It is possible. Though we have set out 40, but it is possible that by repetition method the exact angle which is there is 41. Okay, so this is the angle 43, 26, 41. So our angle alpha here is less by 2 seconds from our desired angle. So what should we do? Because we cannot set out 2 seconds. Well, for this length, if I draw a perpendicular here and I know this length d, we can compute what should be this distance d small d, because we know this angle is 2 seconds. So if it is so, I can compute the distance d, and what we can do, we can set out the angle now in such a way that our actual angle becomes the angle between this line, and after setting out this distance we get a point and we get this line. So our actual angle which we wanted to set out is this angle. Again, if you want to be more accurate, we can further measure this angle by repetition method in order to know whether it is within the permissible limit or not. Well, in case of total station, what will happen? Total station does provide more facility of reading and setting out the angles automatically. So if the angle is in multiple of least count, we can set the angle in the total station, and the total station will automatically take that much rotation. So we can set out the angles that way in the case of the total station. However, here also, if the angle to be set out is smaller, or rather I should not say smaller, rather the precision of the angle is not, or rather the angle is not the multiple